All right, we're going to go ahead and start the new chapter since, we took a test, and so it's time to start the new chapter. We are going to be on chapter 7. We're going to start with 7.1 polynomials, and this will be on page 324. We're going to start with taking some notes, so make sure you have this in the book. This is what I'm going to be looking for when I take grades, this one especially. Okay. What you need to do on page 324 is you need to go over and find all the highlighted words and define them in your book. I'm not going to do that. You can do that. I am going to focus on the first one, which is diagonal. Okay. A diagonal of a polygon is a segment that joins two non-consecutive vertices. Okay. So we're going to do that, and we're going to look at kind of the first theorem here, but we're going to look at a little table here. So we are going to look at a bunch of different polygons, and we're going to look at some information about those polygons. So we're going to have the number of sides for the polygons, the number of triangles / the number of diagonals, and then the total of the interior angles. So we're going to do the sum of the interior angles. Okay, so that's what we're going to look at here. All right. So we already did triangles, so I'm going to fill that one out. We know triangles has 3. And number of triangles, well, it's just one triangle. And we didn't talk about diagonals during the triangle chapter, so probably that's going to be 0. Okay, and we'll explain why. Total of interior angles, well, that should be 180, right? Okay, so going on to quadrilaterals. We know that's 4 sides. Okay. Number of triangles. Well, we need to get triangles. We need to basically break this up with diagonals. Reason why we learn triangles first is because every other shape can be broken up into triangles. And so a diagonal is you start at a vertex, which is one of these points, and I want to do it says here, non-consecutive vertex. So this would be a consecutive one. So the only non-consecutive one would be over here. All right. So that would be a diagonal. So it looks to me like the diagonal breaks it up into 2 triangles, leaving one diagonal. And so it looks to me like, I know that like a square, a rectangle is going to have 90-degree angles here. And so I bet you that's going to add up to 360. All right, so let's see if you can do the diagonals for this one. Okay, this is not a regular pentagon, but it's still a pentagon. And so let's look at this here. So obviously this has a 5-sided shape. And let's see, I'm going to start here. Okay. Looks like I can divide this up into 3 triangles by drawing 2 verticals. Okay, and I will tell you, and we're going to look at this and see a pattern, that this is going to be 540. All right, the last one we're going to do until we get down to this next one. So this would be 6. That would be a hexagon. So let's just go ahead and do this guy right here. Okay. I have 1, 2, 3, 4 triangles. 1, 2, 3. And this is going to be 720. Okay. So let's look at this pattern. Of course, 3, 4, 5, 6, and we're going to do an n-gon. An n-gon is basically what you can call something that has just a whole bunch of sides, something that you don't necessarily have the name memorized. So if it had 17 sides, we would call it a 17-gon. If it had 400 sides, we'd call it a 400-gon. Okay, you are going to have to memorize all the way up to 12, and then so memorizing all the way up to 12, names of polygons, page 28. They leave out 11, and it bugs me, so an 11-sided is a hendecagon. And I don't know what I did there. Hendecagon. Okay, so make sure you have that down. So going back to this, an n-gon. So if we have big-sided shapes, we're just going to call it an n-gon, like I said, 17-gon. Would have 17 sides. All right, so we're going to try to predict how many sides an n-gon is going to have. Well, it's going to have n sides. We're going to try to predict how many triangles and how many diagonals it's going to have. Okay. So it's looked to me like, well, triangle has 1 triangle, square has 2, 3, 4. So it looks to me like, looking at these numbers, how would I get from here to here, or here to here, or here to here, or here to here? Looks to me like it's n number of sides, and I think it's the same every time. What is it? What do we think it is? How do we get to 5 to 3? 4 to, we're definitely subtracting. Looks like we're subtracting 2 every time. Okay. Let's look at diagonals. Okay, 0 diagonals, 1 diagonal, 2 diagonals, 3 diagonals. Looks like we're doing the same thing, except for n2. Okay. But the main number I want is the one in black. I just wanted to show you the diagonals. Of course, you could draw diagonals from every vertex, but just from one vertex, that's how many diagonals you can get. So we're going to use this black number here to do this last little bit. Total of interior angles. Well, 180, 360, and I told you the rest. It forms a pattern. Okay, and this is what the pattern it forms. Well, I have 1 triangle. All those angles add up to 180. If I can have 2 triangles, all those add up to 360. Okay, because basically a quadrilateral is just 2 triangles glued together. Well, this is 3 triangles, and so I added 180 again. This is 4 triangles, so I added 180 again. So this means that the number of triangles, that's the number of triangles in an n-gon, times 180 is going to give us the total, okay, of the inside. So that was basically just a walking through theorem 7.1. Okay, so 7.1 gives you this formula. I'm going to let you copy that down on your own. That's theorem 7.1. This is the explanation of it. So this is the interior angles. Now we had a triangle, an exterior triangle theorem, an exterior triangle angle theorem. Now we're going to have a theorem 7.2 is a polygon exterior angle theorem. So let's go ahead and look at that. Okay, and so I'll draw a little shape for you here. Okay, so there's the interior angle theorem and the exterior angle theorem. Okay, and to get those exterior angles, I'm just going to extend these lines like this, like this, like this, like this. And this is not a regular polygon, and that's okay. So if I'm going to add up 1, 2, 3, 4, 5. So this is theorem 7.2. And I want you to write that down. I'm not going to do it on video because you can do it. We're on page 326. Okay. And so no matter what I do, they're always going to add up to 360. Okay. So interior changes based on shape. This doesn't. And the reason is because the distance around anything, the distance around a circle, the distance around any shape is always going to be 360 degrees. If I start here and go all the way around, it's 360. Okay? And so if I add up all these angles, it's going to add up to 360. So that's there. I think I'm going to give you the book assignment today, if this is 2021. But I think I'm going to let you do it digitally. And so I'm just going to kind of go over a problem that you can get. Okay, so I'm just going to look at 3. And it should be the first one on your assignment here today. It says find the sum of the measure of the interior angle. I'm on page 328, by the way. The sum of the measure of the interior angle of the indicated convex polygon. Okay, nonagon. Well, I know a nonagon has 9 sides, and so I put it in my theorem. So I'm using that first theorem, 7.1. So that would be 9 minus 2 times 180. So that's 7 times 180. And that's all calculator. So that's going to give you 1260. Okay, next set. And this is probably your 5th problem. The sum in exercise, the sum of the measures of the interior angles of a convex polygon. Classify the polygon by the number of sides. Okay, so I'm going to do this one, and it's probably your number 5. So, but it's 7 in the book. So this is 720. Well, that's the final answer. So how would I get there? Well, 720 is going to equal n minus 2, 180. That's the formula, right? So I'm going to divide, bam, bam. That's how I'm going to start. I don't really want to do the distributive property. You're allowed to do this, so I do this first. So we know it goes into 720, what is that? 6 times? 5 times? Four times? One of those. Which is it? 4? N minus 2. And now you figure out where I got 6. So the number of sides is 6, which would make it a hexagon. Okay. I don't know why I made that so small. All right, so that's 7. Moving on to 11 through, or the other set, you're just solving for x. There are tutorials for those. The only tricky one is, so it probably is going to be your, that's 8, 9, 10, 11, 12, 13, 14, 15, 16. Your 16th is difficult. So your 16th problem will be difficult. And it is going to be, it's because of the number of sides you think it is. It's 1, 2, 3, 4, 5, 6, 7, 8. It's 8 sides. And you're going to think it's 7, but it really is 8 sides. Okay. All right. Then we are going to find the measure of greater than x and y. I'm sorry, angle x and angle y. So I'll do one of these. This is 19 in the book. And this is going to be a big, long assignment. In 2021, we're probably going to take 2 days on it. And so you will be fine. Just to make sure everybody can work out getting it done. So 19 looks basically like this. I'll freehand it. It's ugly. I'm sorry. Okay. Okay. So basically this is what it's going to be. All right. And so I know what this is. I don't need that box. I could call that 90, right? And I know that this is going to add up to, let's see, 1, 2, 3, 4, 5. 5 sides. So if it's 5 sides, that means that it's going to add up to 540. So the total is 540. Well, how am I going to figure this out? What are those going to equal? I know they equal the same. I don't know what they are, so I'm going to assign it a variable. Okay, so I'm just going to go ahead and I got 2 x's here. And I'm going to go ahead and add that up. $656, and I'm going to work it out from there. So it should be this. Uh-oh, that's not 656. You guys are going, what did you do? I typed it wrong, see? Oops. That's not right. So if it doesn't make sense, double check it, because that didn't make sense to me. I was just going to go with it, and I was like, no, I can't. I have to resist. That looks more reasonable. And so that would be 184 equals 2x divided by 2 divided by 2. So that would be x equals 92. Okay. And let's double check. I forgot what this says. Find the measures of x and y. Well, I didn't label it, but that is x and that is y. And so the answer is both of them equal 92. Okay. So that's that one. We're moving on. We're going to move on to the next one. And of course, this would be probably a good stopping place for your first day. Once you get to these kind of questions, then your second day, you can do your next set of questions. Okay. So here we go. The next set of questions is find the value of x, but we're now dealing with exterior angles. This is 23 in your book, but it's not going to be in your computer assignment. Okay, and I know it's exterior angles because they draw the shapes weird, like this. So 65, 106, 78, x. Like I said before, it doesn't matter how many sides. Each shape's going to be different. I know that they're all going to add up to 360. So that would just be x plus, I'm not going to work this one out, I'm just going to set it up. X plus 65 plus 78 plus 106. And I just, in general, like to simplify, combine like terms before I write it down. Okay, make sure you got that right and written down, and then you just minus 249, and you got your answer. And your answer should be 53. And is that right? No. Your answer should be 111. 111. All right, moving on. 27. And I'll just read the directions because you're going to get there. Find the measure of each interior angle and each exterior angles of the indicated regular polygon. Okay, so that means find both. Okay. So it doesn't want the sum, it wants both. It wants the individual angles of both. And so a pentagon is 5. And so I'm going to come up with the sum first. So interior angles is going to be 5 minus 2 times 180. And exterior is just going to be, well, exterior is just 360, right? Okay. So this would end up being, 540. All right, and this would be 360. But it doesn't want the total, the sum. It wants one angle. And you can't see this. It just wants one angle. Okay, so this is a 5-sided shape. How would I find out what each angle is in is it regular? It's a regular polygon, right? That means all the angles are equal. And so if all the angles are equal, I find the average angle. How many angles are there? So that's how I find the average angle. Same thing with the exterior angles. There's going to be 5 angles. They all add up to 360. The average angle, you divide by the number of angles, and that's how you get the answer. Okay, so 540 divided by 5. 108. And 360 divided by 5. 72. All right. I think that's the hardest. I'm going to give you a couple other ones challenging, see how we do on those. Remember, I'm going to set it up where you can try it as many times as you want to. And so, yeah. Yeah. All right. See ya.